Welcome back. Today let's talk about the internal architecture of 8085. It was the first commercially successful MUP from the Intel. Before going to the architecture of 8085, let's have a closer look to the memory. From the previous video, you know the flip-flops as the primary memory elements. They together make a register. An individual memory location is an 8-bit register no matters whatever microprocessor you are studying. 8085 has some general and some special purpose registers. We will talk about them later. So this is your semiconductor memory already interfaced to the MUP. Hope you see the memory select. It's a decoder like that we talked about in the last video. Each memory location has an address and it contains some sort of data. You already know it's only zeros and ones. Now we are ready to jump right into the architecture. Instead of getting the whole complicated lecture at once, let's grasp the small pieces one by one. This is the skeleton. No need to worry about. You need to focus only where I want you to. These 6 are the general purpose registers. Programmers use them as variable. You must remember that you are gonna code into the assembly language. They're pretty closely hardware stuffs rather than softwares. So you don't have int I kind of variable stuffs. Here you use your general purpose registers as variable. Each of them are 8-bit registers. Though you can use these pairs as register pairs when you need to. Then you can work with 16-bit data at a time. This is your PC, that is a program counter. PC holds the address of an instruction for you. Well, we'll modify the previous statement later. Just work with it as for now. Let's say PC contains a value 3000 hex. It's a 16-bit number. I hope you know that by now. Each digit in hex is represented by 4 bits, remember? Please check out the previous video if you don't. Let's move on for now. So PC has a value and it's an address of an instruction that is stored in the memory as its binary form. Now to get it, PC releases its value. To carry 16-bit value, 8085 has a 16-bit address bar. The higher nibble of your address, that is 30, comes through A15 to A8. The lower nibble comes through 87 to 80. There is a mere difference between these two sets. The lower order address bus is also used as a data bus. So they are written as 87 to 80. A for address, D for data, you know, right? Why? Because address and data never work together. Remember this thumb rule. You first give address, then you deal with data. Don't worry. We will talk more about multiplexing later. So now, this value 00, the lower nibble of the address comes through 87 to 80 to the address latch. And at the same time, 30, the higher nibble comes through A15 to A8. Address latch is already enabled, so 00 gets logged in the other side of the latch. Address latch is something that is used to separate data and address. So you get 3000 hex here. After it comes to the memory select, the particular location with address 3000 hex gets locked. Now let's see what data it is holding. It seems like it is holding 80 hex. Guys, don't freak out. I'm sure it's holding the 8-bit binary form of 80. I have written the hex form only to keep things clean. Alright, let's move on. 80 is released and it travels all the way through the data bus and comes to the instruction register to stay for a while. It completes the fetching of the instruction. Then it comes down to the instruction decoder. Here it's been decoded. Remember? Fetching, then decoding. What next? Right, execution. But wait, we are forgetting something for sure. PC has released its value long ago. It's just sitting there idle, doing nothing. So let's increment it so that we can get to the next instruction immediately after we complete the execution of the previous one. You know, memory locations are piled in a top to bottom fashion. That is, we start working on the upside, then come down steps. So PC has to be incremented as memory address gets increasing downwards. So we can say that PC holds the address for the next instruction. Now as decoding is over, the decoder tells the timing and control circuit what it has to do now. So it releases certain signals that does the execution all over the MUPI. Now after decoding, it has been found that 80 was the opcode for an instruction add B. Okay, so you might wonder that add B to whom and where do you store the result? Remember, in 8085, both of these locations are accumulator. It is another general purpose register we haven't talked about yet. So after decoding the instruction add B, timing control circuit tells the register select to select the B register, and then B releases its value. It's storing 30 hex. So 30 hex is released and then it comes along the internal data bus to a temporary register. Here is the accumulator, the most important and badass register of all. A is holding 39 hex. Accumulator and temp releases their values now. They come along to ALU, the arithmetic and logic unit. 8085 has an 8-bit ALU. Timing and control circuit has already told the ALU to add the operands, so it's gonna perform the addition and send the result back to the accumulator. I hope you kinda know by now that accumulator holds the result after each and every ALU operation. Still we are left with three things. One is a flag register, another 8-bit register, but special purpose, not general purpose. You have no access to them. Such more special purpose registers are WZ, SP, that is a stack pointer, and the last one is incrementer and decrementer. Remember the incrementing PC by then? This register does the job. I'm gonna talk more about flags, stack and multiplexing of buses in the upcoming videos. Stay tuned for that. So the things we take out from this video are: the PC holds the address of the next instruction. It's a 16-bit special purpose register. All the general purpose registers are 8-bit storage. Higher order and lower order address buses have a mere difference, 8-bit ALU. Accumulator holds result and the first operand for every ALU operation. Hope you have understood the stuffs we are talking about. If you have any doubts, let me know down below at the comment section. See you in the next video. Until then, enjoy 85.